Alright, so the purpose of this last video is to take a look at everything that we've done so far with polynomials and to try to get a nice accurate graph, taking into account the degree, the end behavior, how many turns, what are the x-intercepts, how does multiplicity affect those x-intercepts, what is the y-intercept. So we're going to take all that into account and we're going to introduce one new little thing when we're describing end behavior called limit notation. Alright, so when we're looking at this problem, I'm just going to ask you a series of questions about f of x, and then we're going to answer all those questions and use our answers in order to graph the equation. So if I were to take a look at this and say, what is the degree of the polynomial? If you remember, what we said was, in order to figure out what the degree is, count how many factors there are, counting all the duplicates. So in this case, I would say 1, 2, right? Because squared means there are 2x minus 5. So 1, 2, 3. This is a degree 3 polynomial. Okay, a degree 3 polynomial has a negative 2 leading coefficient, which means instead of it being the standard down up, the negative sign turns it to up down. Okay, so here's the first new thing that you're going to see. Instead of just writing up down, here's what we're basically saying. Okay, there's going to be a graph, and it's going to be up on the right. Okay, it's going to be up on the left and down on the right. Okay, so it's going to look something like this. Okay. And so we need to describe that in a little bit different way. So here's what we're going to say. Essentially, as the graph, and I'm just going to use the graph and then we'll erase it. Okay, as the graph goes, the x numbers get bigger. It looks like the graph is going to go more and more down. Okay, so here's the way we're going to describe that. Okay, as x goes to infinity. Okay, and what that means is that this number is getting larger and larger, and infinity just means the largest number you could think of. Keep going, right? So we're saying the largest, as large you can get in the positive direction. As it keeps getting larger, we're going to say that f of x, which is the function, what's coming out of the function, is going to go down forever, which means on the y-axis, going down forever means it's going to go towards the negative numbers forever. So we're going to say f of x approaches negative infinity. So we're saying as the graph gets larger on the x-axis and goes towards infinity, when we go down the y-axis, it's going towards the negative numbers, and it'll keep going forever to negative infinity. Okay, we can do the same thing. Okay, talking about the other side, we can say as x approaches negative infinity, okay, which means it's traveling forever to the left, the graph is going to go up. We have the up arrow on the left-hand side, so it's going to go into the positive direction forever. So we're going to say f of x, okay, goes to infinity. Okay, so this is just a new way of describing the end behavior. Instead of just saying up and down, we're actually saying as the x numbers get larger forever in the positive direction, the y's get negative forever in that direction. Okay, so we're and then as the x-axis travels to the left, which means we're going towards negative infinity, the largest negative number you can think of. Okay, as that happens, okay, we're going to say that the y values, which remember f of x just means y, f of x travels towards the positive y values forever. Okay, so we'll see more of those. We're going to do some additional examples. Okay, we're going to say how many max turns does this have? In this case, it has a maximum of degree minus 1 turns. So if this degree is 3, it has 2 turns. Okay, my x-intercepts, I'm going to say when x minus 5 equals 0 and when x plus 1 equals 0, those are my factors. They're each going to contribute to 0. I end up with 2 x-intercepts. My x-intercepts are at x equals 5 with a multiplicity of 2. And x equals negative 1 does not have a multiplicity, or it has a multiplicity of 1, which means we don't need to make any statement about it. Okay, so we're going to take all this information, and we're going to graph. Oh, let's do y-intercept, and then we'll graph it. Okay, for the y-intercept, remember, we're just going to take our function, and we're going to do what happens when I plug in 0. So in this case, I'm going to do negative 2 times 0 minus 5 squared times 0 plus 1. Okay, so in this case, this looks like negative 2 times negative 5 squared times 1. Okay, that's the simplifying those, just the inside of the parentheses. Well, negative 5 squared is 25. Okay, 25 times negative 2 is negative 50. Negative 50 times 1, still negative 50. So I'm going to say in this case, f of 0 is negative 50. Okay, so now let's take all this information and put it on the graph. Okay, so I'm going to say at 5, 1, 2, 3, 4, 5, there is a 0. At negative 1, there's another 0. Okay, I know that at 5 I'm going to have parabola behavior, right? So it's going to bounce. Okay, I know that this thing needs to be traveling down away on the right side and up on the left. Okay, And I know it needs to hit at -50. So again, we might have to count by fives here. So let's count by 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. Way down here would be -50 if I'm counting by fives. Okay, so I need to just take all this into account now. So at -1, okay, I have normal end behavior, which means normal behavior, which means it's going to travel straight through. Okay, so let's see if we can get a slightly more accurate arrow there, because this needs to head all the way down to that y-axis, okay, that y-intercept point before it turns and starts heading back up. So I know that it's going to be heading out of this in a straight line, okay, and then down it's going to be in a straight line, and it needs to somehow get all the way down here, okay, and then it could potentially turn. It might keep going, right? So maybe this will travel down more and then it'll turn up here, okay? We don't know where exactly it's going to turn, okay? So we'll have it travel down a little bit more, okay? And then it's going to head back up at some point, okay? And I know, here's the new part, when it gets to 5, right, 5 has a multiplicity of 2. So because it has a multiplicity of 2, it's going to act like a parabola. So it's going to hit this point, and it's going to bounce, and then head back down. So I'm saying this is potentially a graph. Again, we don't know how low this gets. We don't know how sharp the turns are, how flat it is. But we can say that this is a pretty good sketch of what this graph is going to look like. Okay, so here's another example. Again, we have this new limit notation that we have to talk about. Okay, so I'm going to look at this one and say, all right, I need to find the degree of this polynomial. Well, this one is not in factored form now. Because it's not in factored form, I can just look at the highest exponent. Looks like it's got highest exponent of 3. So this is also a degree 3. Okay, this one has, in this case, again, up-down end behavior. It's up-down because we would like it to be down-up, or it's usually down-up for a degree 3 polynomial, but because this has a negative leading coefficient, it's going to switch from down-up to up-down. So this has up-down end behavior. So again, the way I describe that, we're saying as x gets larger in the positive direction and travels towards infinity, because it's traveling down on the positive side, so you can kind of think of this, when we say up-down, this is the negative x, negative infinity, and this is positive infinity. Okay, so I'm saying it's kind of like, as this thing travels towards positive infinity, okay, we know that the graph is going to head down, which means that f of x is going to go towards negative infinity. Okay, and then the same thing's going to happen as x approaches negative infinity, which means as it goes to the left, we're saying that the graph's going to head up on the left-hand side. So we're going to say that this travels towards positive infinity. Okay, this has 2 maximum turns, again, because it's just degree -1. Now, for my x-intercepts here, I don't have it in factored form, so I can't actually just set things equal to 0. I have to factor it and solve it myself. Right? So I'm going to say in this case, if I pull out a negative x, it looks like I'm left with x squared plus 2x plus 1. Okay? If I pull out a negative x, that's what I'm left with. Okay? Now I need to look at, okay, x squared plus 2x plus 1. What does that factor into? Oh, it looks like it factors into x plus 1 times x plus 1 with that negative x. So it looks like I'm going to get 2 zeros. Okay? I'm going to get, when I set negative x equal to 0, I get 0 as one of my intercepts. Okay? And I can set x plus 1 equal to 0, and I'll get -1, but I'm going to say that there's a multiplicity of 2, because I have a bunch of x plus 1s. I have 2 of them, so I have to count each of them towards my multiplicity. Okay? For my y-intercept, again, I just need to set the original expression equal to 0, and watch what happens here. When I say f of 0 in this case, I get negative 0 cubed minus 2 times 0 squared minus 0. Okay, well, if I were to simplify this, this is just 0 minus 0 minus 0. Still 0. So it looks like 0, okay, or 0 comma 0, is my y-intercept. Okay, so if you notice, my x-intercept and my y-intercept in this case are exactly the same number. So I'm going to put down those points. 0, 0, and -1, okay, 0. Okay, so now we need to take into account all of this information that we have. Okay, we know that this graph has up-down end behavior, which means coming out of this point, it's got to be traveling up. Okay, and coming out of the left-hand point, it's got to be traveling down. Okay, at -1, which is my left-hand point, it has a multiplicity of 2, which means it's going to act like a parabola, and it's going to go down, hit that, turn, okay, And then I eventually need to go through 0 in a straight line because it has a multiplicity of 1, right? There's only one of those, right? So I'm going to say when I turn, okay, it's going to turn and travel through at a straight line and look something like that. Okay, so this would be again a reasonably accurate graph of what negative x cubed minus 2x squared minus x is going to look like. Okay, so I'm going to stop the video. There are two more examples. I'm going to split it up into two different parts so that you can watch it in bits and pieces as you need to. The next two are going to be, again, just different examples where the multiplicities might be different and where the end behavior might be different, and there's going to be some more examples of writing in limit notation. So I highly recommend that you watch the second part.